Alright, so today I'll be talking about Edwin Hubble. Hubble was born in 1889 in Missouri, and he was very bright as a child, very avid reader and into science. And one of his early inspirations was from his grandfather when he had one of Edwin's papers actually published to the newspaper, and this article was about Mars. After beginning his career as a lawyer, Hubble turned to astronomy. And his breakthrough came in the 1920s when he used the Mount Wilson Observatory's 100-inch Hooker telescope to make observations that would forever change our understanding of the universe. At the time, the most common view was that the Milky Way galaxy was the entire universe. But Hubble's detailed observations of the Andromeda Nebula, which we now know today as the Andromeda Galaxy, revealed that it was, in fact, a separate galaxy, which was located millions of light years away from the Milky Way. This was a very radical discovery, and it expanded the known universe beyond our galaxy, showing that the universe contained countless other galaxies, each with its own stars, systems, and mysteries. Related to galaxies, Hubble's most significant contribution to physics came with his study of the movement of galaxies. In the 1920s, he observed that galaxies were receding from Earth, and more importantly, the farther a galaxy was, the faster it seemed to be moving away. This relationship became known as Hubble's law, which states that the velocity at which a galaxy moves away from us is directly proportional to its distance. Although this may sound like a simple observation, in reality, it was a revolutionary one. What Hubble had discovered was one of the first major pieces of evidence for an expanding universe, a concept that would have a very large impact on physics, particularly the fields of cosmology and general relativity. Hubble's idea of an expanding universe is very closely connected to Albert Einstein's theory of general relativity, which describes gravity as the curvature of spacetime. Einstein initially dismissed the possibility of an expanding universe, believing that the cosmos was static. However, when Hubble's observations showed that galaxies were receding from one another, it became very clear that the universe was indeed expanding, in line with Einstein's equations. Although at the time, Einstein famously called this realization as his biggest blunder. Hubble's law was also very key in the confirmation of the Big Bang theory, which proposes that the universe began from a singularity, which is a point of infinite density and temperature about 13.8 billion years ago. The expanding universe that is suggested by Hubble provided the physical evidence that our universe had a beginning, which had very large implications for both physics and as well as philosophy. Hubble's work did not just change cosmology. It also opened up new questions and pathways in physics, especially regarding the fundamental nature of space, time, and gravity. If the universe was expanding, what was driving that expansion? And how does gravity affect the large-scale structure of the cosmos? These are questions that would later lead to further discoveries, including the work of physicists like Stephen Hawking, who explored the implications of the Big Bang and black holes, as well as Alexander Friedman, whose equations predicted an expanding universe long before Hubble's discovery. Hubble's contributions were also essential to the development of something called a cosmological constant, which is a term introduced by Einstein to his equations to allow for a static universe. After Hubble's findings, this cosmological constant was reinterpreted as a form of dark energy, which is a mysterious force driving the accelerated expansion of the universe. And this is a concept that is still a very key focus of research in theoretical physics today. Even decades after his death in 1953, Hubble's legacy has continued to shape the field of physics. In summary, Edwin Hubble's contributions to physics were not just about observing distant galaxies. They were about revealing the fundamental laws that govern the universe. By demonstrating that the universe was expanding, Hubble provided a key piece of the puzzle that would eventually lead to our understanding of the Big Bang, general relativity, and the continuing evolution of the cosmos. His work reminds us that physics is not just a study of abstract principles, but it is rather the search of the deeper truths of existence. Truths that Hubble was able to introduce, truths that are still extremely relevant today, not only in the field of cosmology, but in the field of physics as a whole. Thank you.